A, side of angle A, right? So you can look at the second one. So we have this sine of side A, sine angle A, sine of side over side A, sine angle B over sine of side B, and sine of side C over side C, right? Sine of angle C over side C, right? So this is for spherical triangle. So how do we use it? So now you can apply this one to just, it's not only the right angle triangle, now it's any triangle, okay? So last time when we do Napier's rule, we achieve a 90-degree triangle now. So now we don't need 90-degree, right? There's three angle here. Let's say a triangle ABC. The side B is 80-degree, and then angle B is 120-degree. Angle A is 40-degree, right? Find the side A here, right? So, well, you draw the triangle. Angle A equal 40, angle B 120, and then side B opposite angle B is 80. So we want to find side A. So you can do this if you know two sides and one angle. Then you can use this to find using the sine rule, all right? So this is how you do that. Okay, let me show you here. Okay, sine rule here. Sine A, sine angle A over side A here. We want to find out what is the side A here. Sine angle B over side sine B here. So you can arrange the sine of side A here. So you'll find that after computation, you'll find that sine 40 got sine angle A 40, sine of side B is 80, sine angle B 120. So you can find that this is 46.58, 46 degree, 58 minutes here. Now, bear in mind that we also have this kind of relation for sine, okay? So sine always has cosine don't have this problem. Sine always has this kind of problem, okay? Sine of 180 degree is the same as sine of 180 degree minus theta is a sine of theta. They give you the same value. So where to find the theta already? There's another angle is 180 minus theta. So you can take 180 minus 46 degree, 58 minutes here, and then you find it 135. Okay, 135A. But then you reject in the triangle that, okay, 40 degree is less than 120 degree. So side A should be less than 80 degree, right? Side A, the opposite angle B is 80 degree. So whatever side A must be less than 80 degree, right? So you must reject this 135. So you know that the side A is 46 degree, 58 minutes here. So this is example 3. So I have WhatsApp this to you. Okay, CoC3. Okay, so I'll let you look at the solution for our first before I move on. Okay, so if there's no issue there, I move on to example 4. So continue with the sine rule here. Okay, example 4. Okay, so this one, let's see. Spherical triangle ABC have a side A 50 degree, angle A 45 degree, side C a 60 degree. Use the law of sine to find angle C. Oh, this one is a difficult question. The solution shows that there are two possible answers. Okay, so there are two possible answers now, okay? So anyway, the same sine law can apply. So what do you draw, right? So let me show you the picture, what I initially draw. Okay, so what? Okay, what I initially draw. Okay, let me show a picture here. Okay, so I have a triangle ABC, right? So, okay, the ABC here. So you can draw ABC. Okay. A, B, C. All right. So angle A is 45 degree. Side A is 50 degree. And side C is 60 degree. Use a sine law to find angle C. Where is it C here? Okay, so let's try. So I can use a sine law. So you have started with sine. I want to sine angle C, right? So you can start with sine of angle C over sine of side C, right? Use a sine law for spherical triangle. So whenever read the question, you make sure that you read correctly. Spherical triangle and normal triangle are different. So this is spherical triangle. Spherical triangle. So you watch out because your question in the MST and exam, you may have spherical triangle or normal triangle. So you watch out here. Rule are different. And then in this case, there is no 90 degree, right? No 90 degree. So you need not to do Napier's rule, all right? So you can use general sine rule here. General sine rule also can use for triangle with 90 degree, right? You can actually apply it also, as long as you know one angle is 90 degree. So now I want to find, this is A here. So this A here. This C here. This angle A here. So I know angle side on side C here. So what do I have? Other information. B. So I can use sine angle A. I know angle A here over sine of side A. since I know this one, okay, since I know this one and this one, so it's here. And I also know this one. So I can rearrange to find, not this one, sorry. This is not this I know this one, right? So the sine angle C here. So I can load sine of angle C here is equal to sine of side angle A, sine of side A, then sine of side C now, which I get sine of angle A is 45 degrees. Okay, sine of side C 60 degrees. Then sine of side A 50 degree here. So the press the calculator, show you the here. So this is let's find out here. Okay, sine of 45 degree times sine of 60 degree divided by sine of 50 degree. Okay, so this is 0.979 7993 5995. So C in this case is sine inverse of the answer here. So we get a shift sine inverse the answer. Okay, then you get 53 degree 4 minutes. Right, 53 degree 4 minutes here. This is angle C. Okay, so is the angle C all right? So this is actually 53 degree 4 minutes here. Looks clear. Okay.
Yes, sir.
Yeah, so 53 degree 4 minutes here. Okay, angle C. Okay, is it reasonable? I think the looks like comparable, right? That we know in our 45 degrees correspond to 50 degree, and this one 53 degree 4 minutes correspond to 60 degrees C. Okay, looks okay. Now let's try to find, because we know there is an issue for sine here. Usually we have this. Okay, so you have a theta here. Then you can another theta here. 180 minus theta, right? So we know the sine of theta is the same of sine of 180 minus theta. So you can actually look for another angle is that, or C is this one, or C is actually okay. C is actually equal to 180 subtract 53 degree 4 minutes here, and then you get 126. Okay, this 126 here. Okay, 126 degree and 56 minutes here. So is it possible? Okay, this is also another possibility. If you draw a triangle differently. So the way is this one is actually, okay. So if I draw this one, you can see picture, this picture, I can draw this way. C is here. So that this angle is 126 degree 56 minutes. Okay. Another possibility. And that's why this answer is tricky. Okay, so this is how you get this solution. So I WhatsApp this solution to you. So we have talked about the sine rule for spherical triangle. So the next one, let's look at cosine rule here. Right? Okay, let's recall the cosine rule here. Law of cosine shows if you plane triangle, you have a angle A, B, C, and then side. A, B, C, they are measured in kilometer, meter, nautical miles. Angle are measured in degree and minutes here. So this is the plane triangle. But spherical triangle. So you can draw a triangle here. All right. So this is ABC now. Okay, then you label the side A here, side C here, and B here, right? Now the answer for the cosine rule now. Okay, we have also rule for cosine, right? The cosine of A. Cosine A is opposite here, so I'm going to give you the color here. Just now we have this A here. Okay, A here, and B and C. So B okay, and C. Okay, then this is 2BC minus 2BC, right? Minus 2BC cosine of angle A. This is actually a plane triangle. Now, for a spherical triangle, all the side and angle are measured in degree a minute now. So I can use also sine of A now. Sine of A, not sine A, cosine A now. Cosine A here. So this is cosine A here. This is the cosine angle A here, right? Corresponding. Then all the, wow, it's not so complicated as one. You have a sine of cosine of B first. So cosine of B here, then cosine of C, two sides here, plus sine of B, and sine of C. Then you have a final part is a cosine of A again. So this is how the corresponding part, whenever you're going to turn around, right? So this is law of cosine. What's that this to you? Okay, so next example now. Okay, before example, so is general introduction of law of cosine now, right? So just now I show you is a yellow one, okay? Spherical triangle. You can actually find the B, right? So for example, if you draw the triangle and then want to find what is side B, okay? For example, it is side B now. I use a color. So if you start with this one, side B here, yellow one, side B here, the last one is angle B, cosine B, right? Then together, the adjacent of angle B is A and C. So there's an A and C here, cosine A, cosine C, right? Then sine A, sine C. And this is how you apply this law of cosine. So generally, if you know two sides and one angle in between, you can actually use this cosine rule. Cosine rule is very simple to use and very convenient to use, because wherever you get, you don't need to use a sine rule again or find the other angle, right? For sine rule, we have to find two angle. Okay, one of the theta, the other 180 minus theta. But cosine rule don't need. What you find angle is actually the as the answer now. So let me WhatsApp this to you here. So this one might. Okay. So again, this one here. To see that, okay, you can actually change the formula. So WhatsApp this here. And you compare this to the spin triangle. Again, there is no mention about 90 degree, right? So you can actually apply this cosine rule. If the triangle have even 90 degree, right? So actually apply it also can, all right? Just one angle is 90 degree now, right? So this is actually the right here. Okay, so you can do this to find the side. Okay, also find the angle, right? You have to rearrange them to find angle. So to find angle here. Okay, so how to find angle? So I rewrite this for you here. Let's see. I start with this formula. Begin with this one. Okay, cosine A equal to cosine B, cosine C, plus sine B, sine C, then cosine A again. So this is actually, I use the first formula. Usually people memorize this one. Okay, cosine A, cosine A. Then next to cosine A, you have B and C here. So you have cosine C, B, cosine C, and sine B, sine C, right? So afterwards, what you do, you subtract cosine B, cosine C. So you get equal to sine B, sine C, cosine A. Okay, so we get this one. And you want to make cosine A the subject here. So divide both sides by sine B, sine C. So you can do this for cosine A, right? Then how do you do the same thing? You want to find the angle B now. You can change the A to answer B, right? So just remember, if you want to find cosine B, in this case, it's just all the C, right? You have to use replace one cosine B, right? You must replace A by B. Right? You can do accordingly. You want to find cosine B there. Okay, I look at here. So if I want to do the question, second one. So you want to find cosine B here. So it can be here. So you can be yellow. Then A and C are the green now. Okay, so you get, okay, cosine B, cosine the side B minus cosine side A, cosine C, then divide by sine A sine C, and this is cosine B. It's quite easy to memorize. Change the equation around. So this is how to show the cosine B, right? Show you how to change the formula accordingly. Okay, by using the color. So let me use the color here. So I get ABC there. Okay, A, B, C. So this one is B here. This is A here. This C here. So I use the color here. Then let you see that this is actually coming from here. Yellow one. Okay. And then this is a green one. Okay, so let me assign this to you. Okay, law of cosine is very friendly because you don't need to worry about the answer. You get only one answer only, right? When you do a calculation, you get only one answer. You don't need to find the other answer, unlike the law of sine, right? It's 180 minus theta again. Okay, so move on. Example 5 now. How to find this one. So let me write this for you again. So example 5. As you see that there is only one answer only. When you use the triangle. So this one is spherical triangle XYZ now. So we can draw a triangle XYZ here. XY is one side XY is 110, side YZ is 63, and angle Y. So let's try the triangle here. Okay, XYZ here. So X, Y, Z, all right? So you say XY is 110, side is XY is 110, 27 degree, 110 degree, 27 minutes here. YZ is actually 63 degree, 42 minutes here. Angle Y is 94 degree, 21 minutes here. So ask you to find exact. So I'll use the color code first. Okay, I want to find exact here. So I'll use this. So exact is yellow here. And then this is 110. And this is the green color one. So apply a formula now. Okay, yellow code here. So one of them is cosine of xz here, okay, yellow one, equal to cosine of xy, use the green color one, then cosine of xyz here, then plus sine of xy, sine of yz, then cosine of angle y. So you can use the color code to see the relation here. This xz here. Okay, this y. And the center here, yellow color one. And then these are the xy, yz, xy, yz here. Okay, so put inside there, cosine of xz here, it's cosine of xy is 110, 27 minutes here, and cosine of yz here is 63 degrees, 42 minutes here, plus sine of xy here, 110 degree, 27 minutes here, and then sine yz here, 63 degree, 42 minutes here, and then cosine y, 94 degree, 25 minutes here. So you press calculator. So let's find out there. So this cosine degree 110 degree, 27 minutes times cosine 63 degree, 42 minutes plus sine 110 degree, 27 minutes times sine 63 degree, 42 minutes times cosine 94 degree, 21 minutes, right? So this 21 minutes here. All right. So look at this, minus 0.2185. So exact first answer is cosine inverse. This is the only answer, right? Then you get cosine inverse. Shift cosine inverse, the answer 102 degree, 37 minutes. Okay, so this is how you get example 5. Okay, so that is example 5. Very straightforward application. So next one, I'm going to do example 6 here. Okay, so here's example 6 here. Finding angle now, right? Just now I'm finding side. So this time I find angle. Same thing for the law of sine and law of cosine. You can actually apply to spherical triangle with 90 degrees, right? You can also do that. But this is for general spherical triangle. A spherical triangle ABC. So let's try ABC, AB, AC, and BC, right? So the small triangle here. So AB, side AB is actually 50 degree 10 minutes here. Okay, this is actually side C lah. And then AC 64 degree. This is actually side B here. 64 degree. Seventeen minutes here. And BC, we know side BC is actually side A now. 27 degree. And 37 minutes here. So draw a triangle to understand the situation. Okay, law of cosine. Okay, find angle B. So I want to find this one. Okay, so let's slowly evaluate the situation. So whenever you have two sides and one angle in between, you can use the cosine rule here. What I'm going to do is I use the color code here. So I have this is B, side B, this is cosine B here. And then this one is actually side C here. This is cosine B A here. Side C. So to start with, you don't want to memorize too much formula. Okay, so I'm going to start from scratch here. So you know that cosine of the side B, right? Cosine of side B here. Okay, this is the standard formula is cosine of side A, cosine of side C, right? 2 and C here, A and C here, right? Plus sine of side A, sine of side C, and cosine of angle B. Okay, use the color code here. Okay, so the color yellow, and then two sides are green. Okay. So I know I want to find the angle here, so you look at here. So you have this one I don't know, I want to find. So sorry, this one I know. So you can find out indicate I have this one, I have this one, I have this one, I have this one, I have this one. Now this is I don't know. Right? So here rearrange them. So you can get cosine of B here. Then minus cosine of A, cosine of C. Okay. Then equal to sine A, sine B, cosine of B. Okay. Then rearrange them. Cosine B minus cosine A, cosine C over sine A, sine B, C here. There's cosine B. So now put in the value of B here, 6417. So cosine 64 degree 17 degree. Okay, 17 degree here. And minus cosine A is actually 27 degree. -37 here. Then cosine of C now, 50 degree, 10 minutes. Then divided by sine of A, which is 27 degree. Then sine of C. Okay, this is cosine angle B here. So now try to find cosine B now. See why this angle. So yeah, press calculator here. Cosine of 64 degree, 17 minutes minus cosine 27 degree, 37 minutes times cosine 50 degree, 10 minutes. Then divided by sine 27 degree, 37 minutes, and sine 50 degree, 10 minutes. Okay, so again minus 0.73754. So from here, I know what is cosine B now. B is equal to cosine inverse, whatever answer you have. So cosine inverse here, shift cosine inverse answer. Okay, this is actually 112 degree, 3 minutes. So 3 minutes, so easier by this way. So this is how you do example 6 here. Okay, so let's see any more. Okay, so let me say what the MSC will cover, right? MSC will actually cover until here, okay? Until here, okay? Your MSC until law of cosine. Then the rest will be pushed to exam, okay? So the MSC is actually for beginning, revision tutorial, and chapter 1, or chapter 1 about bearing until chapter 2, Napier's rule, until law of sine, law of cosine. So we stop here, okay? The rest, now leave it to exam. Okay, then how about the topic we have? Let me see whether I have this. Continue here. Okay, so let me talk about the other things. Let's see where can I go. Lesson 5. Let's see what I can do. Just to level. Okay, so what I'm going to tell you about this. Okay, let me share the screen for you here. Okay, so then between example 3 and example 4, then there's a 4 parts theorem, right? So you can skip the 4 parts theorem. Okay, can skip a 4 parts theorem and then go straight to application to navigation. Okay, so we'll teach you application to navigation. This is what I intend to do. So you can skip the 4-part theorem. So all the tutorial on 4-part theorem, and skip them. Okay. So let's see how much I can do for you here. This is application on navigation now, right? So we actually look at how to apply it to the Earth. Right? The Earth in North Pole and South Pole, right? So what happened is, how do you measure 2 points on Earth? Okay, so especially we're interested in the great circle distance. So to measure the distance between 2 points, let's say A and B on Earth, okay, point A and point B on Earth here. So we usually let the travel be along the great circle's track. Great circle is actually the biggest circle on Earth here. Okay, so the coordinate we know on Earth have longitude, latitude. Okay, and the North Pole and South Pole are the 2 points on the Earth there. So usually very similar to bearing, where we look at bearing here. So what is the, you can see the diagram. If a ship move from A to B, right? So the ship move from A to B. So let me show you here. This A to B here. Now, usually from A to B, now you can join the North Pole. Join the North Pole first. North Pole is P. Okay, the P here. So join the North Pole, you have the meridian. So this is from the North Pole here. So this direction toward North Pole. Okay, the angle between the track of the ship and the North Pole to the North Pole is the angle alpha. This angle alpha is indicated in blue color here. This is called the initial cos. Okay, now at the point B, okay, you can join the point B to the North Pole again. Okay, join the point P to the North Pole again. Okay, and along the track, right? This is the track here. So this angle in the green color one, this is the track here. Just now the track is this one, right? Follow the track here. Then you find that angle beta, we have a name for this. It's called the final cos, right? From the North Pole, measure from the North Pole to the angle, the final track. This is called the final cos here. So initial cos is between the North Pole and the track of motion, track of the navigation, all right? And then from B to the North Pole, then I measure the angle along the track here and direction of movement. That's called final cos, right? So just give you the idea where this can come from. So let me shift this a bit on my here. Okay, let's look at more information about this one. So I have the diagram of the Earth here, the equator that pass through the equator, right? You can see the track here from A to B. I use a yellow color, okay? Yellow color from A to B, right? So let me erase the color first, that you see everything, okay, A to B first. So you see that alpha and beta are the initial cost and the final cost here, right? Great circle final cost here. So I have alpha and beta. So this alpha beta here. Okay. Initial cost, final cost. The P is a North Pole. I'm going to explain to you what is PA now. PA is the distance from the A to the North Pole. So we call it co-latitude A. Co-latitude A, right, is actually distance from North Pole to the point A. Co-latitude A, so that I use a green color here. PA, right? How about PB? We also call another one PB, co-latitude B. This is a definition, huh? Okay, then the distance between A to B, right? We call it great circle distance, okay? Great circle distance between A to B, right? So this one, you follow the great circle, okay? So this is actually the great circle distance now. Great circle distance, right? We also have a name for P, right? P is the difference between the longitude between A and B. Okay, P is the distance between the longitude A and B. Yeah. Now there is a question about something called a vertex here. What is a vertex here? Right? Vertex of the great circle is the point from the surface of Earth which is nearest to the pole. What does it mean nearest to the pole? So if you draw carefully, the nearest point to the pole may be in this way. 90 degrees. So this line is called vertex here. P, vertex here. This is the nearest point from the track to the pole. It's called a vertex here. So there are actually two vertex, okay, because you can measure to the North Pole and also sometimes the nearest point to the South Pole also. And that's why two nearest point. At the vertex, the angle is a z 90 degree, okay? 290 degree or 270 degree, depend on whether which direction the movement is. So this is called a vertex here. So vertex actually this one. Right. So, okay, so just WhatsApp this to you first. I'll talk about this in the next section. Okay, so well, I'll stop here, okay, and continue the lesson on the Thursday. All right. So then I want to talk about this one because this one will be more involved already. So we'll continue the tutorial on the what are the tutorial now we intend to do. Okay, you can see that we are going to do tutorial 2, question 7 to 12, right? Question 7 to 12. We do 1 to 5 already. So it's left is 7 to 12 for okay. Okay, so 7 to 12 we'll do on Thursday, right? That'll be all for today. Thank you very much. And there's the other question. Okay, so this is the last slide we have. If not, then you can leave also. Okay, stop recording already.